Good morning, everyone. Thank you very much for making it. This is AWC webinar number 30 now. My name is Alex Fassini. I'm the Business Development Manager here at AWC Solutions. Today, we are joined by Bennett. And you know what? I'm not going to try pronouncing your name, Bennett. I know I remember seeing it on your card where you even had the phonetic pronunciation around there, but one way or another, I'm going to butcher it, even when you're spelling it out. But Bennett is here from Graver Technologies. For those who've been here before, thank you and welcome back. We have touched on medias before, and the reason why we're going into adsorption media is, when you're going into heavy metals, which we're working on a lot with some arsenic and uranium and more of those, is we're always considering ion exchange, which we've already covered in the webinar series. We've also looked at reverse osmosis, which of course has its considerations, but we've never really focused on the ion exchange portion. On the adsorption media. So I guess I can also just go through here just to have a look at some of the ones that we've covered. Part of the AWC webinar, we've really gone down the list. This is actually now number 30, and yes, we've been doing it now for all of 12 months. It's been a year. We started in June, and now we're going through this one. So, oh, Paul, thank you for making it. This was actually Paul's suggestion. We are working on a couple heavy metal projects. Like I mentioned, we've already done arsenic and uranium, and we've touched some of the alternatives, but we never actually got into the final one. And yes, I can say that it is my preferred method of treatment. So just a quick background on AWC. You all know we've been around for close to 40 years now. We have close to 600 plants, water and wastewater treatment plants worldwide. We do divide everything into 3 categories. These are all turnkey plants, so we do everything that has to go into potable water, wastewater, and skid-mounted systems. Now, what makes it very unique with adsorption media is because it is adsorption, it can't fit into a gravity clarifier like we do with some of our DAFs or other medias. It does need to be pressurized. So you would be typically seeing these as a post-polishing stage with anything else. So in some of these projects we're looking at, we'd start with a clarifier, like a tube settler, and then from there pick it up with absorption clarifier. So with that, I'm going to bring it over to you. So Bennett, take it away.
Thanks, Alex. Are you going to be running the slides?
Nope. Go ahead and share your screen.
Okay. And let's see. I can share my screen. It'll oh, okay. Does that work?
Yeah.
Everybody can see that?
Yeah, we can see it.
All right. Well, thank you, everybody. I am Bennett Buchsieb, and I'm responsible in handling North America for the granular product for Graver Technologies. And my background is very extensive in having dealt with a number of different systems, technologies, valves, pumps, controls. I do have a mechanical engineering degree, and I started out in the wastewater treatment side of things 20 years ago. So I've seen the water and the wastewater. So it is something that AWC and all of you get to have access to, is that knowledge and applying what we're going to be talking about here. So I thought I would talk a bit about Marmon. Marmon Water is a $1 billion division of Marmon, and it's made up of a number of divisions where Graver Technologies, right in the middle, that is the division that is handling the adsorption media. And well, Marmon is owned by our friend Warren Buffett. So I've always liked the fact that I see Fruit of the Loom right up there on front. That just always, it just reminds me how diverse he is. So going into adsorbents, I'm going to get kind of a generic here so that we can all have a kind of a background foundation here. So what is an adsorbent media? Of course, there's other things, and we can always look at other options and other ways that it's done. But as a rule, organics take up organics. and that's going to be your GAC and PAC. Now, when you're talking about when you need to take up metals out of water, that's when you're going to use metal-based granular media. So the most common one out there, aluminum oxide, because it's so inexpensive, but it has its downsides. Iron oxide, very prevalent. Titanium dioxide, that is our Metsorb, that's Graver's product. And there are others out there, but others probably on this call will say, oh yeah, I've heard of X, Y, and Z. It's like, yeah, but these three are the most dominant players in metals taking up metals by adsorption. So what are the advantages of adsorbents for metal removal? Well, probably the most prevalent one is extremely simple to operate. I mean, all you need are a couple vessels, put media in, you may or may not even backwash depending upon the operation, and you just start going. You can remove multiple metals at the same time, which is and what's different is you don't get the rollover like ion exchangers GAC with the preference. There isn't preferences going on. So when you take up a metal, arsenic and uranium, you take them up and they are attached to the media and they will not come off, no matter how much other metals come along. So when a media truly is exhausted, it's exhausted. Another great advantage that we see when it comes to like impacted waters from seawater is TDS. Chlorides, carbonates, sulfates do not impact the performance of what we're trying to do, which is the take up of metals. Now, it doesn't mean other things won't impact us, and I'll go through that real quick. But as a rule, TDS in its basic form does not impact us. Another huge component of adsorbent medias is they are disposed of as a general rule, non-hazardous, depending upon which one you use. For our media, it's always been non-hazardous. Other media, sometimes you can or cannot be non-haz. And goes back to simple operation. You can do smaller setups. When you have the right water quality, you can get much smaller footprints in your treatment systems, which is a big advantage for your customers. So where do we commonly use it? It is the most common way, and we're talking the majority of the way the product is used, is you're taking parts per billion range of whatever metal contaminant you have, and you're taking it down to a lower parts per billion range. Generally, at the beginning, you're always going to be non-detect for the ones you're really going after. And examples, 100 parts per billion. And, you know, you might see from mining operation or something like that, and you have to go to drinking water standards. This would be a perfect opportunity. Another one would be the most common that you see in drinking water is 15 parts per billion down below 10. That's a good example. Another one is uranium. And again, this would be another one where you take it up non-detect until you eventually get breakthrough, exhaust the media, and then you replace it. So you use it in tailings, dewatering construction, and potable systems. In dewatering construction, you see a lot of applications where multiple metals are need to be taken out at the same time because regulations just seem to be getting tighter and tighter and tighter. I mean, we're talking, I have one project in Wisconsin where during the process, the regulators took the arsenic level down during the process. So they have to look at, additional treatment. Customers want simple operation. That's another common use. A lot of times you can get away with no chemical. If you have extreme locations, as you're going to see in mining applications, and less water waste. I mean, all the way up to you can set up the media to never be backwashed in certain circumstances. So in my life of working with all the different regulations from surface water discharge to mining, remediation, and to potable drinking. These are all of the metals I've seen at some point or another have a regulation. And you see on the drinking water, of course, those are prevalent both in Canada and the US. The only difference in Canada, you folks up there don't like uranium as much as we do, so you have a lower level on that. But this is everything that, as a rule, adsorption media should be able to take up all at the same time. Very important. So going to, wow, this is great stuff. Well, what do we need to consider? Well, unless you have a very unique situation, parts per million of levels of anything is just going to be too high. You're going to generally, it's going to be too difficult, too expensive, unless, again, you have extreme circumstances that just require you to use adsorption for any number of reasons. Zero liquid discharge, for example. That would be a good example. And there are interferences that people, all of, in dewatering, potable, they just don't care about. Phosphorus, that'll impact the life of the media. Silica will impact the life of the media, as well as iron and manganese, but you can take those out generally with coagulation filtration process, oxidation filtration. So those generally aren't an issue. And the other thing to consider, do you really need to backwash or don't you need to backwash? So, and that goes back to zero liquid discharge, low liquid use, low liquid waste. What are the priorities for the customer? And final slide here, everybody. Can you believe that? This is a pretty quick presentation. And this is me being allowed to advertise a little bit. So this is our MetSorb line. And HMRG is what you'll see the majority of. That's the majority of the product we sell. Heavy metals removal granular, really technical term. Yeah, got it. And extra rinse is just an example of where we will rinse it for you so you can apply the product. You can apply the product without having to backwash. HMRP, that's where people use that in carbon block that you'll use in your sink or under your sink, and we own about 30% of that market. And STG is just for industrial applications where you have heavy lead, heavy zinc, nickel, cobalt applications. And MOX is, we are getting ready to present out there for fluoride removal, and we're currently piloting that and finding great success. And now we just need to finalize that in the next few months, and it'll be out in the marketplace. And that is it for my presentation. I want to thank you, everybody. Are you going to take it back here?
Thank you, Bennett. Yes, that's perfect. Yeah, I think that we covered everything. You know what? We hit it right on the line, so we can open it up for questions. I've got to say, this is probably one of the first times that when we sent out the webinar invite, I received more questions via email, even before we had the presentation out there. So we can go ahead and open it for questions. And if not, I can start with some of the questions that I received via email. I can get started on actually, I have a question. You had mentioned that there's no need for backwashing. So how do you deal with, say, bed expansion, going through a nice even flow for your columns?
How do we deal with bed expansion?
Yeah, if we're not backwashing, is there an alternative to it? Are you running it in upflow versus downflow?
You're running downflow, but all medias, all adsorbent medias need to be backwashed because in the process of being manufactured, they have particulate, they have residuals in them that need to be gotten rid of. And we just have a process where we eliminate all of that for certain installations. where you can install it, forward flush 1 or 2 bed volumes, and you're off and running for the life of the bed.
Right. So they're very short backwashes. It's not like you're actually doing any kind of regeneration, like you would typically see in ion exchange. Okay. Another question we had here was on pH dependence. How pH dependent is this media?
It depends upon the metal, but this, as a rule, works within the standard water quality parameters. So 6.5 to 8.5. For certain metals, depends upon the pH. Lead likes higher pHs. Arsenic likes lower pHs. The lower you go, the better it'll do.
Okay, even below that 6.4, 6.5 range, the lower it goes, the better it would?
It'll work all the way down to 4. It'll the capacity will go through the roof with a pH of 4 on arsenic.
Okay. And then a question about the media disposal. I know that you'd mentioned that this can be disposed like just traditional landfill. Is there any regulations as far as what it is you're treating for if you're going into lead versus uranium for media disposal?
Yeah, when it comes to municipal, when it comes to regulated sites, it has to pass the T-clip test, the California wet test in California, and I can't remember what it's called up in Canada. And maybe Alex, you probably remember what it's called up there.
Yeah, I honestly don't, but yeah.
But it's a toxicity leaching test, and there's certain metals that can't come off. And depending upon what you're taking up, it can impact if it passes. Activated alumina doesn't pass quite as often as iron media, and we always pass because titanium dioxide holds on to the metals much stronger than the other medias.
Yeah, from what I understand, it literally binds onto the media where you can't really break that bond, unlike some of the other metals. Okay, and then the last question I have for today before we wrap up was regarding seawater. Can you use titanium dioxide or any adsorption media to treat for heavy metals in seawater?
Yes, there are interferences because seawater is not just salt. It's not just sodium chloride. There are a lot of other metals in there that can interfere. A good one is strontium. And so you have to look at the application, and you have to be specific in what you're trying to get out and what the limits are. Those are obviously very important, what the limits are. But yes, we've used it in seawater before.
Okay, and I guess outside of the metals, would the high TDS or the high chlorides interfere with the media at all? With the life of a media?
As a general rule, no.
No? Okay, excellent. Well, if anybody else has any questions, go ahead and put it in the chat box. These are some of the questions that I received, and interestingly enough, they were before we even got started. So this is great. Well, with that, I do want, of course, do a final plug onto what we're doing on the YouTube channel. All of this is always recorded, and it's always on there if you want to share it or if you want to watch it again. I do have a little announcement. Yeah.
There are a couple questions that came into the chat.
Oh, did I miss those? Oh, sorry about that. Oh, you know what? I didn't. Okay. Let's take a look. So it has, one of them was, can we have a chlorination step upstream of adsorbent bed, and will residual chlorine impact performance?
It will not impact performance. However, we advise to keep the chlorine below 0.5 part per million because it is an organic binder that is binding the titanium dioxide together for us. If you're talking about HMRG, and so that it will break down the binder. So you just keep it below 0.5 part per million. Activated alumina and ferric oxide, you don't have to worry about chlorine ahead.
Okay. And then here it says, what are the typical pretreatment before metal adsorbent medias?
Typical pretreatment is filtration, and it is iron and manganese because they're so easy to take up, and yet they will have such a big impact on life. So you want to take up as much as iron and manganese as possible. So
Yeah.
that's generally the most pretreatment that you'll do.
Okay. And then the last one here, I also have, it says, okay, what about organics? So say COD, BOD, how does this limit performance if biogrowth happens in the media?
Oh yeah, it'll limit performance because organics, depending upon if it's lignins, tannins, if they're large organics, they're going to attach, they're going to coat the media, and of course that's going to blind it. So you do have to be aware of that. Standard levels of 1 to 2 parts per million is no big deal. But if you're coming off a stream that is from a landfill, I mean, there's some nasty stuff in landfills, for example. Those can be some very heavy organics, very large chain molecules that will coat. So you have to be careful of those. And yes, you can get biogrowth. There are certain bacteria that does want to live on it. It doesn't happen very often, but it's just like anything, just like on GAC, sometimes you'll get smell and taste.
Okay, so we've got two more questions and we'll limit it to that. So I've got one here from Eric. A selected media will remove a certain group of metals. We cannot remove one more than the other. Is this correct?
Well, let's see if I understand that question. There is no preference generally when it comes to adsorption medias, but one metal will always have a capacity different from another metal. That is absolutely the case. So we cannot remove one more than the others. Is this correct? That is correct. If you're removing multiple metals, one will always exhaust before the other.
Okay, and the last one, if the system is sized properly, roughly how long should the media last before it's exhausted? Maybe I can take a stab at this. I think we kind of look at it the other way around. You size it based on the exhaustion. So what you can do is you can punch everything in and take a look at it. Okay, we're going to have X amount of bed volumes and say whether you want the media to last you 18 months or 5 years. So you take a look at the media exhaustion as part of the calculations in order to size it properly. Am I doing that right, Bennett?
Yes.
Okay. So yeah, it's not just based on flow, it's how long you're going to be able to get out of the media. So excellent. Well, again, Bennett, thank you very much for doing this. I know it was not quite last minute, but I really wanted to get you on here because we were using adsorption media with some of our applications. Quick announcement. I know it says there, see you in July. We are going to be taking a 1-month break in June. Just give us a month, kind of a breather. We are planning quite a few more of these in July. We already have about 4 or 5 different ones. If you have any ideas, whether it's technology driven or contaminants that you'd like us to cover, please let us know. You can put it in the chat box or even send me an email. My contact information is in there, and so is Bennett's if you want to reach out and if you have any questions. And with that, thank you very much, everyone, for your time, and I will see you in July. See you in about a month. Thank you very much. Bye.
Thank you.